we're going to continue on our factoring trinomials. We really are beginning to hit some of my favorite items. I just absolutely love this. Begin to think of this kind of as a logic problem. I want to do a little bit of review. We really worked with straight lines. You started that back in pre-algebra. We know y equals mx plus b is slope-intercept form for a straight line. We use point slope form, and then of course standard form. Remember, in all of these, the degree is 1. So there will be 1x intercept. Okay, when we get to quadratics now, they have something called standard form. Ax squared plus bx plus c. The a, b, and c are all constants. And what I mean by that is numbers. And in this case, we're going to only continue working with real and rational numbers. Most of what we will be doing will be integers. Once in a while, I might throw a fraction in there, but it will be a pretty nice fraction to work with. A is always the constant in front of the squared. B is always the constant in front of the variable to the first term. C will just be the number by itself. When I give you this, remember this is called factored form. Let's put this in expanded form. To do that, we will FOIL. So I would get x squared plus 5x plus 3x plus 15. Yesterday and the day before, we were working with polynomials, bringing them to factored form. Combine our two like terms in the center. X squared plus 8x plus 15 is standard form. Some things about standard form, please notice we are writing it in descending order. Okay, when you look at this math problem, excuse me, what would be my A in this one? Remember, A is the constant in front of the squared. Well, what number is right there? How many x squareds do we see? Just 1. So there A is 1. B is positive 8. C is 15. So that's my A, my B, and my C. Now, when we look at this one, that is right there. I wondered what I was thinking I was going to do. Okay, we'll move to this one over here because that is done. So my A, my B, and my C. Let's identify those first. A is here, so that's 1. B is there, that's 8. And my C here is 16. Today we're going to be working with trinomials where A is always 1. There's multiple ways of working with this one, but draw an X. Don't make it itty bitty. Make it so that we can write in it. Okay. On this X, we will put the B term here and the C term here. So I have plus 8 plus 16. Now, to figure this out, well, our goal is to get back into factored form. I can't group this. There isn't greatest common factors. So what I need to do is I'm going to look for two numbers that add to 8, but at the very same time, those two numbers are going to multiply to 16. So start thinking of all the numbers you know that multiply to 16 but would add to 8? I bet most of you already know, but I could do 1 times 16. When I add those, though, I get 17 as my sum. Ew, that won't work. I need 8 as my sum. I need a positive 16, so 2 times 8. Oh, but when I add those, I get a sum of 10. That won't work. 3 doesn't go in there. Oh, 4 times 4 is 16. And when I add those, I get 8. So to write this in factored form, it would be x plus 4 times x plus 4. If we took a minute and FOILed this back out, I would get x squared plus 4x plus 4x plus 16. Combine the two terms in the center, x squared plus 8x plus 16, got me to where I started. This will work anytime a is 1. So I'm going to slide over here. I'm going to identify my a, my b, and my c. Remember, a is the digit or the number in front of the x squared, so 1. B is in the center, so 8. And C is the constant with no variable at the end of 7. We put B here and C here. I am looking for two numbers that add to 8, but at the same time, sorry about moving it around so much, multiply to plus 7. So we need them to add to 8, but multiply to 7. This is the trickiest one. This is the one students forget about often. But the only thing I can think of that would multiply to 7 is a positive 1 times a positive 7. 1 plus 7 is 8. 1 times 7 is 7. So in factored form, I would get x plus 1 times x plus 7. Does it really matter the order in which you write these? No. Remember, commutative property of multiplication, you can multiply in any order. All right, to the next one then. A equals 1. B equals the negative 10. Ooh, I'm changing it. C equals positive 24. So I will draw my X. I will put B here, C here. So I need numbers that add to negative 10 while multiplying to positive 24. Okay, let's think about what do you know? What kind of numbers multiply to a positive number but could add to a negative number? Well, they will both have to be negative. Negative times negative is positive, or they would both have to be positives, but we would end with a positive 10 here. So we need to think of what two numbers can I add to get to 10, but using those same two numbers, I can multiply and get to positive 24. Well, if you want, let's run through our factors. 1 times 24, but if I add, they would have to be negative. I would get negative 25. Ooh, that won't work. Negative 2 times negative 12 gets me positive 24, but when I add, I get negative 14. Negative 3 times negative 8 is positive 24, but I'm at negative 11 for my sum. Negative 4 times negative 6. Oh, well, there it is. So if I multiply negative 4 times negative 6, I get positive 24. If I add those two numbers, I get negative 10. So x minus 4 times x minus 6. If we FOILed that back out, I would end at that. Okay. Here is my A, my B, and my C term. Be very careful. So I need numbers that will add to 3, negative 3, excuse me, but multiply to negative 28. Well, that tells me two things. When I multiply and I get a negative answer, one number is going to be negative, one will be positive. But my sum is going to be negative. So will the factor that is the greatest be a positive or negative number? It will be the negative. So I could do 1 times negative 28, but that would get me a sum of negative 27. 2 times negative 14, that gets me a sum of negative 12. 3 does not go into 28. 4 times negative, oh, there it is. That gets me a sum of negative 3. So 4 and negative 7. X plus 4 times x minus 7 gets me factored form, so I can get this trinomial. On this one, I gave you two variables, but we're not going to get stressed. We'll just solve it like normal. Again, there's my A, my B, and my C. I need two numbers that add to negative 9, but multiply to negative 10. So just like in the last one, to get a product that is negative, I know one needs to be positive and one needs to be negative. So I could have 1 times negative 10. Oh, there it is. That gets me a sum of negative 9. So I have 1 and negative 10. They add to 9 and multiply to negative 10. So x plus 1 times x minus 10 would help me get back to factored form. On the next page, there are 4 of them. I just made them a little bigger, but go ahead and solve those. I'll put the solutions on a different video. Please take a minute and factor is really the proper word. Factor those 4 problems for me.